Hello. Hello. Hello.
Am I audible, sir?
Audible only. Okay.
Sir, okay.
Hmm. So here you see some questions I'm giving you, and you need to explain the questions. The question number 1, these problems are from the D block elements. The question number 1, they are talking, why do transition elements exhibit higher enthalpy of atomization? What the reason is? Enthalpy of atomization means to convert into atoms. Getting na?
Getting it.
Hmm.
Sir, these box elements have the unpaired d electron. So the number of electrons is more. So sir, in
So,
the transition element, the number of unpaired electron is more. So they will exhibit the higher enthalpy of atomization.
no, no. What is the enthalpy of atomization? If I will write the enthalpy
The
of
enthalpy of
atomization,
atomization is the energy we can require to break the bond. So sir, now here we have higher number of unpaired electrons. So sir, there are all more number of electrons are involved in the bond formation. So bond is
Ah,
stronger, and to break that bond, the higher energy is required.
correct. Now it is correct. Earlier you are not using the strong bond.
The bond strength
Energy,
needs to be constant, sir, actually.
energy required to convert molecule into atom. Convert molecule into atom. Molecules into atom. So what you are saying, that is absolutely correct only. So they have the transition metal. They are having the strong metallic bond. So a strong bond is there. It means more energy required. Yes or no? More
Yes.
energy required. So that is delta AH is high. So that you already answered. There is no problem. Now the next question. Here they have written the answer. Because of large number of unpaired electron in their atom, they have a strong interatomic attraction. Hence,
Interaction.
interactions. Hence, a stronger bonding between atoms resulting in higher enthalpy of atomization. So that is correct. What you said, that is correct. Now see, in the series scandium to zinc, the enthalpy of atomization of zinc is lowest, 126 kilojoule per mole.
Sir, this problem we discussed the day before yesterday that zinc is
But
having three, it is
hmm,
having no unpaired electron. So sir, this
hmm,
bond is weak. So sir, the enthalpy of atomization is low.
thank you. So no weakest bond, lowest enthalpy of atomization. So they have zinc has completely filled d orbital, do not take part in interatomic bonding, hence metallic bonding is weak. That is why, this is why it is very low enthalpy of atomization. So that is what you are saying, that is correct only. Name a transition metal elements which does not exhibit variable oxidation state.
Sir, scandium and zinc.
Mostly scandium we wrote, but scandium and zinc both are there. According to NCERT, only scandium they have mentioned. But zinc also only represent +2, right? Which transition metal, which 3D element represent +1 oxidation state? +1 also.
Scandium. Scandium.
No. Scandium
So copper,
+3, one
copper, copper, copper.
copper plus, and another is there copper 2 plus. Okay, thank you. So scandium does not show variable oxidation state. Which 3D series transition element exhibit largest number of oxidation state and high? Why?
Manganese. Manganese.
Manganese, because they are having the highest number of unpaired electrons. So Mn is, if you are talking about
4s1, 3d5.
3d5 means 4s2.
4s1, 3d5.
No,
So 4s2, 3d5.
that is why it is going to be +7. Na? Like what is there? KMnO4. KMnO4. So Mn is how much is there? +6, 7. Yes, yeah, no.
Plus 7. Yes, sir.
MnO4 minus, MnO4 minus. So how much is
Plus
there?
7.
Plus 7.
Plus
Hmm.
7.
So Mn is highest. So chromium oxidation stage is plus 6, like CrO3. So here is what is there? Plus 6. Okay, next questions. So here they written, see the among 3D series, manganese exhibit largest number of oxidation state plus 2 to plus 7 because it have maximum number of unpaired electrons. So this is next question. Why Cr2 plus is reducing but Mn3 plus is oxidizing when both have D4 configuration? Can you explain?
Sir, this one I don't have the idea, sir. I have to check.
Okay. See, low oxidation state lose electron. So act as what? So act as, can you tell me, act as losing the electron. So they are oxidizing
Base.
other or reducing other?
Lewis base.
Huh? Lewis base,
Sir,
that
they
is
will
okay. Oxidizing or reducing?
sir reducing.
Act as reducing. Thank you. So that is act as reducing agent. Higher oxidation state. High oxidation state. They are going to gain electron. Gain electron. So gaining electron, so act as what? They oxidizing other.
Oxidation.
Oxidizing agent. Now, you have to compare these two. Which one these two? That is chromium 2 plus. Chromium 2 plus and another is there Mn3 plus. Which one is the lower oxidation state? Cr2 plus. Yes or no? So
Yes.
Cr2 plus, it is configuration is 3d4. It is losing one electron. It is converting into what? Cr3 plus one electron. It convert into 3d3. Now you know splitting up d orbital you study na. Already you study coordination compound. So total electron, how many are there? Suppose total electron are 3, this one. So if you see this condition, so T2G and EG orbital are there. So 1, 1, 1. So this is T2G3 configuration and EG 0. So if what is there? This
Sir,
is
what is
stable
the
half
meaning
fill
of
now.
this one? Sir, what is
What?
the meaning of this one? T2, G3 and EG0, sir? This one I don't
This
know.
is called triple degenerate and this is double degenerate. 3 orbital having same energy, 2 orbital having same energy. When d orbital is approached by ligand, so it is split. If this is split into two set, T2G and EG. We'll study
Sir, what is
coordination.
the ligand? What is the ligand, sir?
Ligand means that donate lone pair electron.
Sir.
So stable T2G. So act as what? It is the giving the electron, act as reducing. Act as reducing. Now, your other one you see, other one what you see, Mn3 plus. Mn3 plus is quite compared to Cr2 plus. Mn3 plus is what? That is higher oxidation state, yes or no? Compared to Cr2 plus, Mn3 plus is high.
Yes.
High means
Hi.
it is going to gain one electron. So it will convert into Mn2 plus. Here configuration is 3d4. Taken one electron. So it convert into 3d5. 3d5 means stable half field. Stable half field 1 1 1 1 1. So it again become what? Stable half field. Stable half field. But what it does, it taken the electron, so act as what? Act as oxidizing agent. Act as oxidizing agent. Can't you understand this?
Hmm.
Can you write this one?
Yes, sir. You make it a little small so that the whole thing comes. And I can
Check.
write. Done,
Now
done.
it is. Hmm. Done.
No, sir. Writing. Still writing.
Mhm. Okay, no problem. Can I read?
Yes, sir.
Hmm. Now we are moving to the see the answer how they wrote. This is NCERT only, not from other book. They are saying CR2 plus is reducing as its configuration changes from D4 to D3. The latter having the half T2G label, half T2G label. We are saying see the unit 9. Unit 9 means coordination compound. Now, second point, on the other hand, the change from Mn3 plus to Mn2 plus result in the half field D5 configuration, which has extra stability. D5 means half field. Done, na?
Hmm.
Okay. 8.4. The E naught value of M2 plus by M value of copper is positive. What is the possible reason for this? Can you tell me? Morning I explained this to you.
Sir, we have this one, sir. Like the E naught value will be the hydrogen enthalpy minus. Like del A minus del height. So that way
Hmm.
it will be possible because the
Wrong,
del
wrong,
A is
wrong.
like
Hey, don't make fool to yourself, okay?
why,
E
sir?
naught value, E naught value depends on, firstly, you learn the concept here. E naught value depends on following four factor. Follow, sum of following four factor depends on sum of following four factor. Four factor. Okay. So E naught is equal to what is there? Delta AH. Enthalpy of atomization is also called enthalpy of sublimation. Then IE1, then IE2, then delta hydration enthalpy. These three are positive, and this is what is negative. Negative. Why positive? These are required. This is the required energy. This is the required energy, means energy absorbed, and this is the released energy.
IE meaning
Ionization enthalpy, first ionization enthalpy, second ionization enthalpy. Now they are saying this is the positive. This is positive means which factor will be positive more? Means what? This is the enthalpy of atomization plus IE1 plus IE2 will be higher. Positive value are higher than enthalpy of hydration. See, consider it's high enthalpy of atomization and low hydration enthalpy. So these value are high positive, na? So enthalpy of atomization is more. So this will come in, not will come positive. Yes or no?
mm,
Understood.
yes.
Write down this one.
Wrote on already written.
Mhm. See how they have written. Electrode potential value is sum of three factor. Here they wrote three factor. Enthalpy of sublimation. Sublimation means atomization. Here you see it is converting into copper atom. Sublimation is nothing but atomization. Ionization enthalpy. Ionization enthalpy, that is IE1 plus IE2. Both
They are
ionization
taking it as
enthalpy.
a whole.
What?
I'm saying they are taking it as a whole.
Hydration enthalpy. Okay. In case of copper, the sum of enthalpy of sublimation and ionization enthalpy is greater than the hydration enthalpy. This is why E naught value of M2 plus upon M is copper is positive. Can't you understand?
Hmm.
How would you account for the irregular variation of ionization enthalpy, first and second, in the first series of transition metal? Ionization enthalpy, you see, firstly it is increases, then become almost constant, and at the end also increase. What is the irregular? Somewhere it
Sir,
is
it
decrease
depends,
also.
depends on the electronic configuration, no, sir, whether it is stable or not. Sir, that is what it depends upon, sir.
Depends on electronic configuration as well as size. Size is also irregular size.
Hmm.
Yes or no?
Yes.
So that is why this is the answer. There is no problem. Now what we can do, next question we are going. How would you account for the increasing oxidizing power of the this one BO2 plus Cr2O2 Cr2O7 2 minus MnO4? How would you account? See, high oxidation state. I told you na, high oxidation state. Just now I told you, high oxidation state gain electron, gain electron. Low oxidation state, low oxidation state, low oxidation state lose electron. That is why Cr2 plus was the reducing and Mn3 plus oxidizing. Now, here if you talk about BO2 plus Cr2O7 2 minus and MnO4 minus. So here oxidation state plus 7, plus 6, plus 5. So increasing oxidation state means increasing increasing tendency to gain electron, increasing tendency to gain electron, to gain electron. So if the tendency to gain electron increases, so act as what? Gaining electron act as oxidizing or reducing?
Oxidizing.
Act as oxidizing. So higher the oxidation state, higher will be the oxidizing power. Can you write this? Done.
Writing.
Hmm.
Hmm.
Done.
Done, sir.
Okay. See the reason what they are saying. This is due to increasing stability of the lower species to which they are reduced. This is not the very accurate answer. Accurate answer I already written there. Now here you see question number 8.6. For the first row transition metal E naught value they have given. Here they are saying minus 1.18, minus 0.91. These are there. And copper is positive. Explain the irregularities in the above value. How can you explain this?
Sir, their ionization itself is also different, not due to the shape, different shape and different electronic configurations. So that is why
Hmm.
the net E net value will also be different.
See, vanadium and Mn are more negative. Why the more negative? If I will ask you E naught value are there, so what you will find? Delta Ah plus IE1 plus IE2, even IE3 is also responsible. For Mn3 plus IE is 3 is also responsible. Plus what is there? Delta hydration H. So why they are getting the more negative? More negative means this is more, and some
And
of these
other
are
one is
going to
less.
be less. Yes or no?
Yes.
So hydration enthalpy is more, you can say, or the enthalpy of atomization is less. That is why they are having the negative, large negative. Let us see the answer. E naught M2 plus upon M value are not regular, which can be explained from the irregular variation of ionization enthalpy. IE1, IU2. Also, the sublimation enthalpy, which are relatively much less, what they are saying, much less for manganese and vanadium. So for manganese and vanadium, it is what we are writing. Also, we are writing less and more hydration enthalpy. That is why they are having irregular trends of E naught value. Is it okay?
Yes, sir.
Can you write you can write any statement if you want.
Writing only.
Mhm.
Done.
Hmm. Question 8.7. Why E naught value of Mn3 plus upon Mn2 plus couple much more positive than the chromium 3 plus to chromium 2 plus, yeah, Fe2 plus to Fe3 plus. Explain. So this is they are talking Mn3 plus upon Mn2 plus. E
Sir,
naught
the
value
IC
they are saying.
is high, sir. That is why.
There is third ionization enthalpy is very high. So more energy required, so positive. That is you explain correctly. Much larger third ionization enthalpy of Mn, where the unpaired changed D5 to D4 is mainly responsible for this. This is also explain why the +3 state of Mn is little important. So you got to know here you see in case of already we know to remove the third electron is very difficult. Yes or no?
Hmm.
So ionization energy is high. Question number 8. Why the highest oxidation state of metal exhibited by its oxide and fluoride only? What is the reason?
So higher electronegativity of oxygen,
Higher
oxygen.
electronegativity. Fluorine and oxygen, they stabilize the higher oxidation state. Correct. Which is stronger reducing agent? Cr2 plus or Fe2 plus? Hmm?
Sir, sir, I think CR2 plus
Hmm. Cr2 plus is the correct answer. Reason.
more negative M2 plus M. That is it.
Hmm. Highest oxidation state it can go +6. Cr +6 means 4 electron it can be capable to remove 4 electron. Now Fe2 plus it can maximum it can go Fe3 plus. It can lose only 1 electron. So which one is able to release more electron? Chromium can release more electron, so its reducing power is high. Greater the tendency to release more electron, more will be reducing power. More will be reducing power. Write down this, please.
Written.
Done.
Hmm.
Okay, next. We are running now for the magnetic properties. Okay.
Yes.
So what is magnetic properties? Can you explain anything about magnetic property? What do you mean by
Sir,
magnetic property?
sir, except for the zinc, sir, in case of this our D block, sir, like transition series, sir, we are having 1 to 9 because zinc will not consider because it has all paired electron. Others will have one, at least one or more also the unpaired electrons. Sir,
Hmm.
that we can that causes the paramagnetic one sir. Or
Um,
in case of zinc, we have the diamagnet.
uh, D block elements are magnetic in nature. Are magnetic in nature. In nature, as they are as they are attracted in magnetic field. As they are attracted in magnetic field. Magnetic field due to presence of what? Unpaired electron. Due to presence of unpaired electron. So because they are having the unpaired electron, that is why they are being attracted in the magnetic field. Okay. Their magnetic moment, they are saying their magnetic moment can be calculated. Magnetic moment can be calculated by
Sir,
formula.
you can send me the notes, sir, after this one.
So mu is equal to what is there in bracket n plus 2. This is Bohr magneton. And here if you talk about n is the number of unpaired electron. This is number of unpaired electron. This is number of unpaired electron. Now, here you see, scandium 3 plus. Here is number of 3d0. Yes or no? So unpaired electron 0. So this is the value of this will be what will be 0. Can't you understand?
Yes.
Okay. Now they are asking Ti3 plus. Let us see. Ti3 plus. So titanium is how much? Titanium is 22. 22 means 3d2, 4s2. Right. Titanium 3 plus. Titanium 3 plus means it is 3d1. So number of unpaired electron is going to be 1. Yes or no? So mu is equal to we are calculating. So root of n in bracket 2. This is Bohr magneton. So what will be there? This is 1 and in bracket 1 plus 2. So it is the root of what is going to root of 3, 1.732 Bohr magneton. Can you understand this?
Hmm.
Okay, so here you see Ti3 plus value how much? 1.75. Calculated 1.73. Observe 1.75. Ti2 plus. Ti2 plus means 3d2, 2 unpaired electron, so 2.84. Can you understand this?
Yes, sir.
And zinc 2 plus is what is they are saying 0. Why 0? Because no unpaired electron. Yes or no?
Hmm.
Okay. Here they are saying calculate the magnetic moment of calculate the magnetic moment of divalent ion in aqueous solution if its atomic number is 25. So they are talking about atomic number is 25. Okay, and this is the divalent. Divalent. Okay, divalent means it is the whatever Mn is there. 25. Mn is 25. They are talking about 2 plus. So if it is Mn, so its configuration is what is 3d5, 4s2. So Mn2 plus it is 3d5. N value, can you tell me N value? How much will be N value?
And value 5.
N value 5. Now we are plugging in the formula mu is equal to root of n in bracket n plus 2. This is Bohr magneton. You put the value of n, what is going to be 2 in bracket 2 plus 2. So it is going to be what? That is 4 to the 8, root of 8. So root of 8 means what?
2,
2 root 2,
2,
2 root 2. So 2 into 1.414. So what will be there? 248, 282, 2.82. So here you see what is they have given. No, array yaar, n value is 5. N value is 5. I am putting that is how much? 2. N value is
but
5.
that is what I
Extremely.
was saying, sir. Why you were putting 2? I did not understand. I was going to
Uh,
ask.
sorry. So here is 5. This is 5. So 5 to 7, 35. Root of 35. So 5 point something will come. 5.92. Done, na?
Writing, sir, writing.
Writing, then okay, no problem. Today, bio madam took the class? No.
Yes, sir. Yes, sir. Took me in the morning.
Acha, that is why you said to take little later. Huh?
Sir, now maths class was there, sir. Night. That is why I told you to take at 11.
Okay, no problem, no problem. Take care of your health also. Do some yoga also in the morning.
Sir will try to.
Hmm. We have to check the health now. That is very important. Can I
Yes,
reach? Can I reach?
yes, yes.
Hmm. Now, calculate the spin only magnetic moment mu for the 27. Z is equal to 2 plus ion, na? M2 plus ion. And atomic number they have given 27. So let us see. 27 means cobalt. Cobalt is 27. So 3d7, 4s2. Up they are saying the 2 plus ion, CO2 plus, so this is going to be 3d7. 3d7 if you are writing, so number of unpaired electron you see 1, 2, 3, 4, 5, 6 and 7. 7 means n value is going to be 3. Yes or no?
Hmm.
N value is 3. Mu is equal to what is going to be? 3 in bracket 3 plus 2. So it is going to be 3 to 5, 5 root of 15. Bohr magneton. So here you can see also root 15, 3.87 Bohr magneton. Can you understand this?
Yes.
So I'm going forward. What is meant by disproportionation reaction of oxidation state? Give example.
Sir, two or more oxidation state are changing. So like one element only that we will find in two oxidation state. So that we will
Okay.
be that we will call disproportionation.
So copper plus is there. Copper plus. Morning we told you that is copper plus is unstable in aqueous solution because it
So
converted
one
into
will be
copper
copper
to.
2 plus, other will be copper 0.
So this is what is the disproportionation is reaction. Means you can write in this one Cu plus 2, Cu2 plus. This is Cu2 plus Cu0. So same element is split into the oxidizing and reducing also. This is oxidation and reduction. So this become the disproportionation. Yes, na?
Hmm.
Next one you see. Here they have given some more other example. They have given MnO4 2 minus 4H plus. They are saying that is 2 MnO4 minus MnO2 plus 2H2O. So here is how much? Plus 6 is there. Here is what? 4 2 ja 8. 8 plus 7. And that is plus 4. So here this is the oxidizing and the same species is here is reducing. That is disproportionation. Yes or no?
Hmm. Yes, sir.
Okay. Explain why Cu2 plus ion is unstable in aqueous solution.
Sir, because Cu plus ion, when it will we are adding Cu plus ion in aqueous solution, then it will become Cu2 plus and Cu0.
It disproportionate. Here they are saying Cu2 plus is much more stable than Cu plus. This is because they are giving some other reason. Therefore, in aqueous solution, it undergoes disproportionation. Since it undergoes disproportionation, that is why unstable in aqueous solution Cu plus. Color of the compound. See color. We are explaining the color. Transition metal. Transition metals are colored. Transition metals are colored as they have unpaired electron. Unpaired electron which undergoes which undergoes DD transition. DD transition. Okay, which undergoes DD transition. That is high low d orbital, low d orbital, low d orbital to high d orbital, low d orbital to high d orbital. So they are jumping now. Jumping means they are jumping for short period of time and then they will fall down. So when they will fall down, they will release the energy that will be colorful in visible region. Here you see there are the three they have given. Most of the compound of transition metal are colored due to first cause is DD transition, second charge transfer, charge transfer where no unpaired electron there, where no unpaired electron, charge transfer is studied, and structure defect, like what will be there, some gap will be there, that will also be colored. So first one we are studying. Free metal ion have degenerate d orbital, which is split into two or more depending upon geometry. So T2G and EG, 5d orbital are there. It is splitting into what? Two set, T2G and EG. Getting? It is the case of what? That is octahedral. And in tetrahedral, they are splitting into T2G is upside and EG is downside, opposite. Now, what is happening here? You need to read. Firstly, when the energy will be absorbed, it is jumping. Then energy loss, this is falling. Falling means loss of energy. And loss of energy is what will be there. In the visible and region, it is colored. So because of DD transition, this is also d orbital, this is also d orbital. It will be studied in the coordination compound much better. So here transition metal compound absorb portion of visible light for excitation of electron from lower d orbital to higher energy d orbital. Thus, those compounds are colored. The absorbed color is complementary to the light absorbed. Whatever the light is absorbing, that is the complementary. Complementary color you must be knowing, na? This is the complementary color. BIBGYOR. Red complementary color is what is there? Green. Blue complementary color? Orange. Violet is yellow and the indigo is also yellow. This is the complementary color. If it is absorbing green, so color will be up here red. Absorbing red, color will be green. Absorbing blue, color will be orange. Absorbing orange, color will be blue. So this is there. Now, the frequency of light absorbed depend on the nature of metal. This is different things, no problem. Now, let us go. When metal ion has high positive charge, high positive charge means no unpaired electron, like KMnO4. MnO4 is +7. So Mn plus 7, Mn plus 7 if you are writing now. So where is the electron? This is the, there is no electron. All the 5 electron, all the 7 electron are vacant. So what they are going, they are absorbing the electron. They are absorbing. So ligand has loose electron. So ligand are giving the electron, like water molecule will give the lone pair electron here. So then transfer of electron from anion to cation takes place. For this process, energy absorbed from the portion of visible light in the compound are colored. So two regions I am explaining. The one region is what DD transition. Other region when the compound like K2Cr2O7, this is orange color, KMnO4 pink color, PbCrO4 that is yellow color. But they do not have, here is +6. They don't have any electron, +6. But they are colored. How they are colored? Because of charge transfer. Getting now?
Yes.
Now, complex formation. They are having vacant orbital, so they can form the complex. Transition metal have smaller size. First thing, smaller size, high ionic charge as well as vacant d orbital. Three factor we are studying: smaller size, high ionic charge, vacant d orbital for bond formation. This is why transition metal form large number of coordination compound, which like this one. They are the coordination compound. So we will study this one coordination complex, but the region is the same: small size, high charge density, and vacant d orbital. catalytic activity. Like, uh, Fe there, na? Fe is there, Pt is there, Pd is there, Ni is there. Okay, Cr2O3 is there, MnO4 is there, minus. They all acting as a catalyst, transition metal, and their compound have catalytic activity. How? This activity is due to ability to adopt multiple oxidation state. Why they are acting as a catalytic activity? Because of multiple oxidation state. Getting my point? Catalyst
Yes.
absorb reactants molecule on its surface and form the bond using electron of d and s orbital. This result in increase in the concentration of reactant at the catalyst surface, and also weaken the bond of reactant molecule and lower the activation energy. Vanadium vanadium pentoxide, V2O5, used in the contact process for the preparation of H2SO4. Ni is used in the hydrogenation. Okay. Finally, divided metal iron. Iron is used in the production of ammonia in the Haber process. So these are the catalytic activity. Why? Because of the variable oxidation state, they are representing the catalytic activity. Yes, Yano?
Yes.
Okay. Formation of interstitial compound. So if you talk about interstitial compound, what are the firstly you understand? Interstitial compound. These are the there. This is the three metal is there. But in the center you will find what is there. Some gap is there now. This gap
Mm.
can be absorbed by H2, or this is hydrogen, or the carbon, or the nitrogen. So when this type of, suppose this is the titanium is there, titanium, and titanium absorb the carbon in the center. So this is what is interstitial compound. This position is called interstitial site. Interstitial site.
Yes, sir.
So here the transition metal trap a small atom like hydrogen, carbon, nitrogen, etc. in interstitial of the crystal lattice. This is called interstitial compound. These compound are non-stoichiometric. Their ratio are not fixed. Non-stoichiometric means there are the fractional ratio will be there, and are neither ionic nor covalent, like TiC, Fe3H, Mn4n. What are the characteristics of interstitial compound? They ask the many type characteristics. They have high melting point because there is no gap. They are very hard because there is no gap. They have chemically inert because there is no free electron. They retain metallic conductivity. There will be the free electron, but they retain the metallic conductivity. So this is the interstitial compound. Alloy
Sir, I
formation.
show me the character one again, sir. Characters.
Mhm.
Done.
Thank you. Next, alloy formation. Alloy are what? Homogeneous mixture of two or more than two metal or metal with non-metal. That is called alloy. They are saying a blend of metal is called alloy. Blend of metal means mixture of metal is called alloy. Transition metal form a large number of alloy. But the point, transition metal form large number of alloy. Alloy are formed by transition metals because of their smaller radii. Alloy are formed by transition metal. Why? Because they have a smaller radii. Alloy are hard and have very high melting point, like brass. Zinc plus copper is brass. Bronze. Copper plus tin is bronze. Steel. An alloy of iron, Ml, Ni, Cr, Mo, etc. or alloy. You read the NCERT, na? NCERT also they have given properly this alloy formation. But for the alloy formation, what will the radii will be similar radii. Otherwise, they are not going to be the alloy. They cannot form the alloy because they are, if the radii difference is very large, they cannot form the alloy. This is. Are you getting this?
Yes, sir.
No.
Getting.
tomorrow morning I will not be able to take the class because I am going somewhere. Evening as usual will take the class.
This time only.
This time only, this time also we can take the class, no problem.
Well, sir, what time you want to take, sir? I can join.
10 o'clock, 10 o'clock.
10 o'clock?
10 o'clock in evening. Now see, the most of the things over. Whatever the properties of the transition metals are there, that we already covered. Like the formation of interstitial compound is there. This already we done. Catalytic activity we done. Alloy formation we done. So some more point they have given that you need to study. They are saying they are formed by such alloy are formed by metallic radii within about 15% of each other. They should not exceed more than 15%. Means they must have the nearly same radii. So tomorrow we are going some important compound of transition metal. Only two compounds are there. That is potassium dichromate and what is there? Potassium permanganate. Two compounds are there. Tomorrow we will potassium permanganate. Tomorrow these two compound will be over and then will become one more class will be required for F block. So two more class required for this chapter to finish. So tomorrow is the Friday. By Saturday, most probably I will finish. Okay.
Okay.
So you just practice this all questions and read out the NCERT if you are having time. Right?
Yes, sir.
Okay. Bye. Na?
Okay, sir. Thank you very much.